Hi there. By the time you're learning about trigonometry, you should know at least the basic formula for the area of a triangle. And you should be able to use it to find the area for a triangle if you've been given the base and the height. For example, in this triangle, you should be able to find the area of this triangle because we have the base and the height. In this other triangle, you can also find the area of it if we have this triangle as a right angle triangle. Obviously, for this second triangle, you need to apply some principles of trigonometry like the Pythagorean theorem, and then you'll be able to find the area of this triangle. However, sometimes the formula area is equal to half multiplied by b multiplied by h might not always work. As you can see in this case, we've got some angles that have been given to us in the triangle and we can't use that formula. So we need to find another formula for area which is going to make it possible to find the area of such triangles. This is Ed Online School. In this video, you and I are going to be looking at trigonometry involving the area of a triangle. We are going to do this in a systematic way, and if you'd like to know what is area, how to derive the formula for area of a triangle, and how to apply this formula in questions, this is the perfect video for you. At the end of this video, we've got some bonus tips, so make sure you watch it till the end to get the maximum value out of it. We're going to define area. Area is the space occupied by a flat surface, or simply the size of a surface. So practically, it's that space occupied by a piece of paper when you put it on a table, or the space occupied by different crops that have been put on a piece of land. Now, in this picture, I want you to see the difference between area and volume. The water here is occupying a volume, while these other two objects, the crops and the piece of paper, are occupying an area. For volume, you can see there's kind of a third dimension or a third value that we're putting in. Usually this is the height. If you are to define volume, you understand that volume is the space occupied by an object. That's a key difference. Now, you should also note that the units for area are mostly square units. So for every unit you have, you're going to have some kind of 2 after it. It's very important to know how to read the units for area right. You start with the square, then the unit. So cm and these two here is simply meaning square centimeters. This is square meters and square decimeters. You should note that there are other units that are not included in this list. For example, the kilometers. They might also be used to find area. Now, let's talk about area of a triangle, which we are totally learning about in this video. The area of a triangle, like you may know, is half multiplied by b multiplied by h. Usually the b is for the base while the h is for the height. When we talk about height under the triangles, we're simply meaning a perpendicular distance from the base. Now, the reason for me talking about the area of a triangle is to let you know that a triangle is just a four-sided shape that has been cut into half. Here we've got a rectangle, so it might mean we are multiplying this b and this h. And now, since we're talking about triangles, we just get rid of half of this and we have a triangle. You can see this triangle formed here is a right angle triangle. And instead of using the L and the B, we use the B and the H. As you can see here, we have a perpendicular distance. It's always at 90 degrees with the base. It's also very important to realize that such triangles have two right angle triangles in them. If we split them in half, you can see that they are actually made up of two right angles. One other thing I would like pointing out about this formula we have here is that no matter how the height looks like, as long you have the height and the base, you multiply them by half, you have the area of a triangle. Even if we have a scalene triangle and we've been given its height, that doesn't look like it's passing exactly in the middle. We are going to find the area of that scalene triangle if we use this formula, as long we get the base and the height. Now, the reason why we're finding a new formula for area is because sometimes we won't be given the height in questions, and so we need to find the formula that will make it possible for us to find the area of a triangle without using the height. However, in mathematics, we'll never run away from using the height. We're just going to find an expression which means the height, but we're not using the height. Now, as you can see, we're going to be deriving this formula using SOHCAHTOA, which is a mnemonic device that we use to remember the trigonometric function and its respective ratios. Obviously, you're used to this procedure I'm going to be doing here. I'm just drawing a triangle and some opposite sides of the vertices that you need to know. If this vertex is A, then this side here is A. And if this is B, this will be B. And if this is C, this will be C. Obviously, you're comfortable with this process. You should note that we'll be using the trigonometric function sine theta, which is a ratio of opposite and hypotenuse. What you should understand when we're deriving is that we are going to divide this triangle into two right-angled triangles. So it means we're going to have an altitude. An altitude is just a perpendicular distance from a surface. Now here, we're going to draw a perpendicular distance from any of these sides, either this small letter A, this C, or this B. We've drawn a lot of these perpendicular distances with C coming to side AB. In this video, I want us to use a different altitude. It's always very important to remember that this altitude is perpendicular, and it's always important to note that after we make this altitude, we have two new things: a point, which we can call O, and a new distance, which is H. Remember, the area of a triangle is half BH. So we're going to be finding the value of this H according to this trigonometric function. Then when we find that expression, we're going to replace it into the formula area is equal to half BH, and we're going to get our new area formula. It's as simple as that. Just like we did, we have two triangles, and then we also have these points here. If you want to get more about what we're doing, watch the cosine rule video and the sine rule video. Here we're going to have a common distance or a common side, OA, which will be H, and we're going to just fill in the remaining distances which we haven't cut into half. You should realize that this BC has been cut into two parts, so we're not going to use it to make this trigonometric function useful. The only thing remaining now is the angles. We have an angle there which will be used as our angle for reference. I like changing this theta to just the letter of the vertex at which the angle is. Now we're going to simply make use of this trigonometric function sine theta and its respective trigonometric ratio, opposite over hypotenuse. We're going to start with this triangle. Obviously, this is the angle we're using, so sine C will be equal to the opposite side of C, which is H, divided by the hypotenuse. The hypotenuse is the angle that is opposite the right angle in a right angle triangle. Remember, this is a right angle, the angle at O. So sine C will be equal to H over B. Now remember, the reason why we're going through this procedure is to find an expression for H. So we're going to make H the subject of the formula. I'm going to divide the left side by 1 so that I have fractions on both sides, cross multiply, and now H is equal to B multiplied by sine C. We do the same for this other triangle. We can derive the formula just from one of these triangles, but I want to show you the difference in how the formulas will come out. In this other triangle, we're using this as our angle of reference, so we have sine B, and this is our opposite, this is our hypotenuse. It's a bit difficult to see in this triangle, but yes, our hypotenuse is that opposite our right angle. So sine B is equal to H over C. We do the same here. I'm going to divide the left side by 1 so that we have fractions. We cross multiply, then find the expression of H. H will be equal to C sine B. You can see from the same altitude we have two expressions for H. This is very important to note. Now what's remaining is just getting these different expressions and plugging them into the formula for area of a triangle. Like I told you, area of a triangle is half BH, and so we're just getting one of these. We can't substitute both of them into the same formula. There's nothing we're doing. That does not make sense. So we're going to get one of these and then substitute them into our formula, since area is equal to half BH. Now, before we substitute the expression for h into this formula, it's very important to deal with the b here. Immediately we begin substituting, it's important that we change the b, which is the base, with the actual base of the height we've created in the triangle. We created the height from the base BC. Therefore, in this formula, we can't keep the b. We're going to replace it with a. And therefore, area this time will be half AH. Everything that remains is simple. It's just substituting and copying what you've already written. So A will be equal to half AB sine C for the first expression here, and then for the second one we're going to have A being equal to AC sine B. You can see from this altitude we have two different formulas. However, just for remembering sake, as you can see, this one is easiest because we have A being equal to AB sine C. They're in alphabetic order, as you can see. Later in the video, I'll even talk about how you can remember this formula. It's not as difficult as it looks like. Now, let's talk about how we can apply the area of a triangle. We're going to use an example. In the example, we've got a diagram, which is a triangle, and then we've got QP, which is the side of the triangle, 8 kilometers, PR, which is 10 kilometers. Then we've been given an angle in this triangle, angle QPR, meaning the angle at P. The question asks us to find the shortest distance from P to side QR. This is not difficult if you've done this before, but right from the start, it's quite a challenging question. In this video, we're going to look at how we can answer this question. Mostly in the ECZ syllabus, what you find is that this question will be the last part of a main question. What I mean is there will be a first part of this question which might ask you to find a missing distance, let's say QR. As you can see, it's the only missing distance. Then you'll be asked to find the area, and then you'll be asked to find the shortest distance. This question won't be posed in such a manner where you need to already know how to answer such a question for you to answer it. Usually it will be a step-by-step question, and then it will be easy for you to answer. But since I know how to find that already, we can skip the part of finding the distance, because you can do that if you watch the video about the cosine rule. And now we're going to practice how we can find the area of the triangle. Area of a triangle is not a big deal. We just need to find two sides that we can use. And as you can see here, we've got PQR, the respective opposite sides for each of the vertices. Area is equal to half QR sine P. This is the formula we'll be using. And then what's remaining here is just substitution. Q is this here, the 10 kilometers. It's very important for you to find which side is Q. As you can see, if you don't, it might be a bit difficult to use this formula. Q is 10, R is 8, and P is the angle at P. Therefore, if we substitute, it will be half multiplied by 10 multiplied by 8 multiplied by sine 92. I'm not going to just multiply everything on a calculator, even though it can be done. I'm going to try to simplify what I can simplify. As you can see, 10 is a multiple of 2, so 2 can get into 10. Therefore, I'm going to cancel out there. If I take a 2 into 10, it's going to give me 5, and 2 into 2 will be 1. Therefore, it's like I've gotten rid of the 2 that was our denominator here. And now it's like I'm multiplying 5 multiplied by 10 multiplied by sine 92. I can also simplify this first part, 5 times 8, without a calculator. So A is equal to 40 multiplied by sine 92. Now we're going to use our calculator to find the value of sine 92. As you can see, that's the value of sine 92. Now we're going to multiply this value by the 40 in advance. My calculator already knows I'm multiplying by answer. Immediately I press the multiplication sign. Now this is our answer, 39.9756, and it keeps going on. It would be helpful if you did this with your own calculator so that you don't have to wait for my answers on screen. Area, as you saw, it will be 39.975 and the other digits, but as you can see, I rounded that value off. Notice that I don't round off my answer right to the actual significant figures that have been recommended by the ECZ. I surpass that so that I can have an accurate answer. I'm not going to round off this answer to 3 significant figures because it's not our final answer. Our question wants us to find the shortest distance from P to side QR. So now it's just us knowing how we're going to use this area to find the shortest distance from this side QR to P, or from P to this side QR. Now, one thing that makes us able to know how to find the shortest distance is the fact that the shortest distance can only be an altitude, or in simpler terms, it can only be a height. So what I mean is we're going to have a certain distance that will come from P and then meet this line QR, which is supposed to be an altitude or a height. This makes sense if you imagine it. If we start taking this short distance, or this distance from P to QR towards Q, you see that our line starts getting longer to be the same size as that 8 kilometers. If we start taking it towards our right, it starts getting longer so that at some point it becomes 10 kilometers. Therefore, somewhere as we are moving this line, we're going to have the shortest distance, and now mathematically that can only be the height. So we are going to be finding the height in simpler terms. Since we have the area, we can use the original form of area of a triangle to find the height from P to side QR. What we just need to do is make h the subject of the formula now. So we are going to simply multiply the bh by the 1, which changes nothing, and then have this new expression, a is equal to bh over 2. Then we divide the a by 1 so that we can have a fraction even on our left side, and then cross multiply. Once we cross multiply, we're going to have the equation 2a is equal to bh. Now our job is getting rid of the b that is combined with the h. When we have two quantities that are combined together by multiplication, we just do the opposite of multiplication for us to get rid of the terms we don't want. So we're going to divide by b on both sides. Hence, on our right side, b will be cancelled, and h will be equal to 2a divided by b. Some students just remember this expression here, 2a over b, when finding the height. It's also another option if you think this is kind of a lot of work, but this procedure here will actually improve your math if you do it often. Now our job is just getting our area and our b. H will be equal to 2 times our area. We've already found our area. Now we don't have our b. Actually, our b is the base. Remember, this formula says area is equal to half the base multiplied by the height, and therefore this b means base. Now, which here of these distances is going to be our base? Well, that distance which is perpendicular to the height is the base, or simply the other way around, the base is the side perpendicular to the height, and so the base can only be QR. QR is 13. If you are wondering how that came about, we had to calculate the size of QR using the cosine rule. If you don't know how to do that, you can check the video about the cosine rule to fully understand how to use the cosine rule and other things you need to know. But here's a quick review of how that can be done. Now, having that let's get to punch this simple calculation onto our calculator and find the value of h. You can see my answer is still on my calculator and I haven't done anything to it, so I can simply just hit multiplication and 2, which means my calculator is going to multiply this answer I had by 2. You can see my answer changes to 79.951, and now I divide this by 13. This is my value, as you can see, 6.150097. When you have these two zeros in your answer, there's really no need to copy them. If you want, you can round it off using this 9 for you to have 6.1501, but that just shows you 6.15 is pretty a good answer. So you agree with me that h is equal to 6.1501, which if we round off to 3 significant figures is going to give us 6.15 kilometers. This 6.15 kilometers is the shortest distance from P to QR. You have successfully reached the bonus tip section. In this video, I've got 2 tips for you. The first is some useful areas in mathematics that you should always remember: the area of a square, rectangle, circle, and a trapezium. This L squared comes about because we've got equal sides in a square. The side here is the same as the side length here. So L times L, if we use some algebra, is just simply L squared. Here we've got different lengths, L and B, and we have L multiplied by B. Here we've got the principle of pi because we're using circular measure. And r is just the radius, which means the distance from the center of the circle to the circumference of the circle. In a trapezium, what you notice is this formula is kind of similar to the formula for a triangle, but for B we have the expression A plus B. Maybe later in other videos we'll look at how this formula comes about, but for now just remember it as it is. The next tip we want to share with you is how you can remember the formula for area. Area in trigonometry will be always half multiplied by a side and another side, which will be multiplied by sine the angle between these two sides. It's always important to remember that we have two sides being multiplied together, then their product is being multiplied by sine the angle between them. If we were to look at this graphically, it means this. If we have a side like this and another one here, the angle we're going to be using to find the area is the angle in between these two sides. It's also very helpful to remember that in this formula for area of a triangle, all the 3 letters used in a triangle will be present in the formula. What I mean is, if we have a triangle ABC, we're going to use 2 sides, which will be obviously lowercase a and b, and then we'll have sine of the letter remaining. If you've been given a triangle XYZ and you've been given the sides y and z, it means you'll be finding sine the angle of x. You always utilize the 3 letters found in that triangle. Thanks for watching till the end of this video. It's your job now to try out some questions involving area, just like we did under the application, and watch out for other videos about trigonometry in mathematics.